Hi everyone, my name is Rich Dudley. I'm the Chief Evangelist for N Software, and today I'd like to talk to you about the old and new of enterprise application development. First, a little bit about myself. I'm currently the Chief Evangelist for N Software, which I joined earlier this year. Prior to now, I was an enterprise developer for over 20 years. Most of that time was just at two companies which valued innovation and technology. Over the years, my interests and opportunities grew my career from a developer to a principal enterprise architect to my current position. I am also currently a Microsoft ASP Insider and an AWS Community Builder. I've worked with major ERP systems, EDI integrations across hundreds of suppliers and distribution points, to cloud-based services-oriented architectures automating the mortgage process. The best part about being at the same companies for so long is you get a chance to see things come and go and to be a part of a lot of changes. That's what I want to talk to you all about today. I'm not speaking to you with the voice of my current role, but from someone who's been part of and led changes in enterprise applications, especially looking back at the last few years. Working in software development, changes are inevitable, whether it's changes in what our applications and services need to do, or changes in how we architect, build, and host our applications and services. Some of the factors driving changes I'm going to discuss today include regulations and penalties. We've all had to deal with GDPR, CCPA, SOX, HIPAA, or something similar, and there's little doubt more regulations will bring more change in the future. Information security, especially protecting critical information through authorization and encryption. Analytics and data-driven approaches to running a business are growing in popularity. This isn't just product development, but measuring productivity and the success of product lines and corporate divisions. The ability to consume and analyze massive amounts of data in near real time is also a driving change. Big data may not even be very big, but it could just be cumbersome to work with using the tools and applications currently in our environment. Automation, doing more with less, and automating a lot of the day-to-day toil. This is both for the business users of our applications, as well as how we build and deploy what we create. And the march of technology, especially cloud, containers, operating systems, and language improvements. The list here is not an all-inclusive list of factors which drive change. One factor not on this list is the COVID pandemic. The pandemic had a massive effect on society, but on its own it didn't directly affect application development that much. Rather, the pandemic did remove the luxury of time to adapt to some changes which were already in motion. An important thing to keep in mind is that change is a good thing. I like to use the analogy that the bicycle didn't fly, the biplane didn't get us to the moon, and what got us to the moon won't get us to Mars. Change is how we take ourselves from where we are to where we want to or need to be. One thing about this talk, there are a lot of slides with text. I really wanted this to be useful on Monday without you having to take a lot of notes or screenshots. If you want the slides, reach out to me, but don't worry about writing everything down. Let's start with a change that affects us developers. Automated build processes aren't meant just to reduce toil. They're also meant to improve the security and stability of our services catalog as well as our software supply chain. Automated processes aren't necessarily continuous. They may start with a manual trigger, but are automated all the way through to a dev or test environment. There's a lot of hand-waving about continuous, but the juice may not be worth the squeeze. An automated process with a manual trigger is usually good enough, and on distributed teams, it helps keep developers from tripping over each other. In many companies, developers also define their own infrastructure, which also gets deployed as part of these processes. This imparts the need for additional security guidelines developers will need to keep track of. If you're not far in the adoption of automated builds, some of the changes you'll see are improved source control, distributed build and deployment tooling, infrastructure as code, and code signing. For years, there has been a move toward right-sizing companies. This doesn't necessarily mean laying off staff. It's more about finding ways to increase production without just throwing more people at a problem. This means automating a lot of manual tasks, especially tasks which can be done in parallel with other activities, whether manual or also automated. More transformational companies ask, before we hire a lot of people, how much of what we need to do can we automate? People in these processes are then specialized to handle the proverbial 20%, or edge cases which are very difficult to program for. The previously used forms to data, data to forms, usually revolved around monolithic systems like SAP or PeopleSoft. People take orders using a screen in the ERP. Purchasing results are run by clicking a button on the ERP screen. Summaries and reports are reviewed by looking at an ERP screen. Resource-intensive activities had to be run in overnight batches, or they would slow down the entire system. There's now a move from forms to data, data to services. This still leaves room for the monolith, but some of the more resource-intensive processes are farmed out to external services, as are activities which can be performed in parallel with the human workflow, or activities that are difficult to add to the ERP system. One advantage of using distributed services instead of bolt-ons to the ERP is that they are much easier to modify, test, deploy, and swap out. This also means that you can move compute to other places. And now, the previously mentioned batch activities can be done in smaller batches in near real time, so someone doesn't have to wait until tomorrow or Monday for their results. These services can also open up new channels, since ERPs and other internal line of business applications are usually not meant for the public internet. By adding a web-based front end, you can reuse these services to take sales orders online, schedule delivery, validate inventory and addresses, and so on in real time. At a previous employer, we did this to great success. While taking a mortgage application over the phone, after we received the subject property address, the processes to verify the address and estimate the home valuation were automatically initiated. We at first thought this would reduce the length of time on the phone, but what we found was the overall length of the mortgage process was shorter by 3 to 4 days because clients had better information earlier in the process and made better decisions. We then had these services at the ready when we decided to build a completely web-based origination process. That saved us years of development. We had already done some of the work. How does this affect what we all write? We'll probably move to having more orchestrated services in our environment, move towards automating manual processes, and easing resource allocations. As our applications shift into a forms to data, data to services paradigm, our architectures are also going to change. They're going to look something like this small example. On the left is a traditional ERP application hosted on a server farm. It covers every task and activity needed by the users. In the new architecture on the right, the main application may still be something like an ERP application, but with a number of additional services to add capabilities, reduce resource utilization, or parallelize activities. In a choreographed service catalog, these new services will talk between themselves. In an orchestration pattern, there will also be a conductor service as well. This drives yet more changes to what we'll write. Every service in our inventory will have to have its own security and communication layers. This is a good time to see if your favorite component vendor has some toolkits to make this significantly easier. It's very likely all of these new services will be run in containers rather than on physical servers or virtual machines. And I come across people who have a deep knowledge of containers and a lot of others for which this is new. Hopefully my oversimplification here will help those of you new to containers without patronizing those of you who are very container experienced. Virtual machines were entire operating systems in a single virtual environment, plus the required libraries, plus the application. As a result, the application was usually only a tiny fraction of the overall size of the virtual machine. The OS on the virtual machine acted just like it was installed on a physical server and handled all the processing and communication with the physical environment. As far as the application knew, it was running on a physical standalone machine. Containers take a very different tack. The only stuff in the container is the application itself, plus whatever dedicated libraries or special tooling not found on the host operating system. Rather than a hypervisor, an orchestration system like Docker or Kubernetes manages the containers. Containers are still isolated from one another, and they're essentially their own little subnet of a physical machine. The upside to this is containers are very compact, very easy to spin up and terminate, and you can run a lot of them on lower powered machines. This makes it really easy to test services on a local development machine in a nearly identical or identical environment to production before deploying to a test environment. The definition of a container is defined in a text file rather than having to be installed completely from an operating system ISO. And build processes with containers can install all the essential libraries, meaning the runtime environment in a container can now be placed into source control and revisions are easily tracked. With virtual machines, you could mix and match host and virtualized operating systems. So on a Windows host, you could run Linux or a Mac OS or Windows, even older versions or newer versions. With containers, you can't. The host and container have to match. This is a lot of what's driving the move to Linux. Microsoft put a lot of effort into containerizing Windows, but as a GUI-first operating system, it just didn't work well. However, thanks to the Windows subsystem for Linux, you can host Linux containers natively on a Windows machine, the same as if you were using a Linux desktop or a Mac OS system. Containerization is often contrasted with serverless, and the compare and contrast is an entire session of its own. There really isn't a right or wrong, just what's best for us. Since I just mentioned it though, another architecture pattern replacing physical servers and virtual machines is serverless. Serverless is heavily promoted by AWS, but Azure, Google, and other cloud providers also have serverless offerings. The author of the image and the linked article calls this a typical serverless architecture. Now, in my experience, there really isn't a typical serverless because the uses are so varied, but this is a good and thorough example, and the article's worth reading. In serverless architecture, we don't have to manage the execution environment like we do in our own data center. We're only responsible for creating the infrastructure and whatever code is necessary for our business logic. All of the communication channels, the security, etc. are managed by the cloud provider. Now, the cloud provider usually has lots and lots of small, specialized services which we piece together into a single application. These services can be API gateways, databases, caches, functions, ESBs, and so on. As I mentioned a moment ago, standalone services all need their own authentication and communication code, in addition to the service wrapper. In some cases, the code to run the services can be more than the code for the business logic, and that's one of the factors which makes serverless a compelling option. Instead of writing code for multiple standalone services, we use infrastructure as code, usually something like Terraform or Pulumi, to define which managed services we want to use and how they're going to communicate. And then we're just responsible for coding the business logic, whether it's in a Lambda function or a step function or in one of the databases or whatever we're using. One of the criticisms of serverless is vendor lock-in. The code for an AWS Lambda function won't run in an Azure function. There is sometimes difficulty in adapting to something so different, and managed services are a bit of a black box with lots and lots of little settings to get just right. Looking at a diagram like this, serverless seems to have an increased complexity because code paths and classes are replaced by managed services and connections, so the dirty laundry is more visible. However, I bet if you diagram the classes and code paths in some of your applications, they would probably look pretty hairy too. A confusion or complaint to dispel about serverless is yes, somewhere in the stack there are a bunch of physical machines. However, the hardware and the Cloud Fabric OS are designed in such a way that the physical machines are abstracted and they operate as one large machine. And the operating system can spread resources out across this abstracted machine, provide redundancy and scalability invisibly to us and the services that we write. It was not that long ago my development team reassured ourselves we would not see a time where Windows wasn't the only operating system we needed to develop for. Well, that turned out to be very optimistic. Today's desktop applications have to work on both Windows and Mac, and we may need a mobile app as well, which is a whole new UI ballgame being touch-based rather than mouse and keyboard-based. Linux probably won't be a major factor in desktops over the next few years, but I've been wrong before. Servers, however, are increasingly moving towards Linux, especially with cloud and containerization. I'm not sure whether Linux or Windows is more prevalent today, but I'd guess in the next 5 years Linux takes a large lead in server deployments. It's difficult to measure this accurately with elastic scaling and containers, so this may in fact be true today. How does this change the applications we'll build? Well, we'll see increased browser-based or cross-platform desktop applications. Now, you can't totally future-proof your technology choices, but you can reduce the risk of OS changes by aligning with companies which emphasize cross-platform capabilities. It's very likely those companies will continue to do so in the future. As a follow-up to the previous slide, authentication and authorization are also changing. Username and password are no longer just enough to authenticate a user. An all-Windows network with Active Directory sure was easy street when it came to securing applications. Just add someone to a group and everything just worked. That environment is quickly going away. Part of what's driving this is Windows, Mac, Linux, and mobile all have different capabilities in authentication and authorization. So the increasing heterogeneity in operating system is driving technologies like OAuth and single sign-on, SSO. Additionally, authentication and authorization often have to be federated with external partners like Salesforce, which have their own authentication and authorization systems built into their own applications. Additionally, the bad guys have better computing power, so if they intercept network packets, they can usually crack passwords and keys fairly quickly. The time-based components of OAuth make this a quantum level calculation, and by that time, the keys have rotated. OAuth and OpenID Connect, OIDC, are used to allow an app or a website to connect to another one on your behalf. If you've connected the Mail app on your phone to a Gmail account, you've seen OAuth in action. If you've used your Google account to log into eBay, that was OIDC. The Mail app or partner website no longer stores your credentials like they used to. Now, you log in to Google directly, and the Mail app or the partner website caches a long-lived token. Microsoft has deprecated the old username and password for many of its services. Those are now mostly OAuth-based. OAuth doesn't just apply to user authentication. Rewinding a couple of slides, OAuth is also used for the service-to-service authentication. As companies use more and more SaaS platforms, there's a greater adoption of OIDC and other SSO technologies. This way, a user's login to a corporate security portal can be used to log in to one or many SaaS platforms. Users only need to log into the portal once, and security can be centrally managed by the security team. It's win-win, so this is becoming very popular. OAuth and OIDC are still largely username and password based, but we now have less and less trust that a logged-in user is actually the user it's supposed to be. To increase our trust, we often add an additional factor to the login process. Multi-factor authentication, especially one-time passwords, OTPs, is becoming more and more prevalent on both the public internet and inside corporate environments. One-time passwords are those 6-digit codes which are accessed in an authenticator app or texted or emailed to you as you provide as an additional factor when you log in. Changes we'll see include supporting some or all of this, depending on what you're building. Zero trust is essentially assuming we can't trust anything. We can't trust the credentials aren't being used by the correct user. We can't trust that the communication channels aren't secure, etc., etc. And so we have to add additional factors to increase our trust in what's happening. There's a migration away from LDAP and Kerberos to OAuth. Authentication will no longer be inherent or invisible. It will be federated with partners, and there'll be a growing implementation of multi-factor authentications. I've just thrown a lot of acronyms at you, so let me try and unconfuse you with some of these. First of all, OAuth. OAuth is an open standard designed to allow an application, such as your Mail app, access to your information, such as the stuff in Gmail. The login used is that of the information holder. In this case, you use your Google login to sign into your Gmail account. OAuth is maintained by the IETF. OIDC, or OpenID Connect, is built on top of OAuth and uses JWTs. It allows one website to use a login from a different website. For example, if you've ever logged into eBay using your Google account, you've used OIDC. OIDC is maintained by the OpenID Foundation. The original idea of OpenID was to be a single sign-on system where public websites wouldn't have to roll their own login systems. They would just trust a few of the big players, referred to as identity providers. Today, there are many OpenID identity providers, including Facebook, Twitter, Google, and Amazon. Since OpenID is an open standard, you only need to implement OpenID once in your website to support all of these identity providers. SAML is an XML-based language for security assertions. This is the format of the messages and tokens that OAuth uses, and that's maintained by Oasis. JWTs are JSON-based standards for holding claims tokens and supporting encryption and signing. That's maintained by the IETF. It's been a proposed status since 2010, but it's pretty well baked right now. And OTP, finally, is a one-time password. That's the 6-digit number from an auth app or via SMS and email that you use in addition to password or having an authentication cookie when it's needed. If you've never seen what the OAuth workflow looks like for a web application accessing a backend service or an API, this is it. This comes directly from Auth0's documentation, and you can see where the tokens are requested and used. The user column includes the UI app, such as a browser, a mobile, or a desktop app. The regular web app is just any backend service that the website your app uses. This diagram also applies to the service-to-service scenario with a couple of changes. Obviously, there's no user, and the regular web app is just any type of service. This diagram has been a good reference for me over the past few years when discussions of how we secure services would arise. For a variety of reasons, fewer and fewer people are working in the office. This is one of the most significant changes the pandemic forced, but was also a growing trend before the pandemic. I've been a work-from-home remote for over 10 years. My previous employer had about 25% of the tech staff and about 10% of the business staff as remotes. We had a good head start when the pandemic forced 100% work from home, and we already had a good idea of what it took to make applications more usable regardless of location. Internal applications and resources now have to be more accessible from anywhere, whether that's home, coffee shop, a plane, wherever. In the past, you'd use a VPN and essentially be on the network business as usual, but VPNs are being phased out, largely because they're expensive, can be slow, and require a lot of care and feeding. VPNs also prevented users from accessing local resources, especially printers, and a distributed workforce often needs local device access. Now, with web-based applications such as Microsoft 365, Google Apps, and Salesforce, users have the expectation that they can just open a browser or a mobile app, log in, and start working. This changes the entire security paradigm of the apps we write and reinforces the need for a good service inventory since browsers are insecure and resource limited. You can no longer count on local processing power. This isn't to say every app can or should be browser-based, but you'll likely be asked to add a web experience where you can. Whether a desktop app or web app, we can no longer act as if the connection is protected by our corporate network boundary and internal security controls. The security of data in flight becomes a principal concern, as does the user and application authentication and authorization. Speaking of data security, it wasn't that long ago that almost anyone could dump a company's data into Excel and do some analysis. As more and more data was accumulated, and especially more and more private data, that turned out to be a very bad practice. People had the ability to access data they really shouldn't have had access to, and they weren't securing it well. The inevitable data releases happened and continue to happen. This has rightfully led to a greater effort to secure data, including where data is stored, how you can access it, what is available, who can access it, and what is encrypted. Complicating this is work from anywhere, where data may now travel over the public internet instead of just inside of a corporate network. Regulations such as GDPR, CCPA, and HIPAA, among others, are focused on categorizing what is private data and how private data should be handled. Regulators have lost patience and penalties are very severe these days. A big takeaway for encryption is to not create your own encryption. This is one of those cases where you absolutely want to buy something and use it. Changes we're going to see in our applications include the need to encrypt and decrypt data in the application. User authentication or service authentication and authorization are also going to be more and more important. Some of the changes we've talked about so far, especially work from anywhere, distributed services, and developers responsible for their own infrastructure, make information security teams more nervous because it's far more difficult to know what is going on. As a result, observability and monitoring are growing trends in application development. Observability can be defined as who, did what, where, and when, and all that information from all users and applications is streamed in near real time to an analysis platform. These observability platforms quickly analyze data and look for operational and security issues. In the past, we often relied on logging and notifications. However, with logging and notifications, we developers have to write the code to produce messages when certain applications are taken or when something goes wrong. This means developers at code time are making decisions about what's normal and what's not normal activities. Alerts are usually sent to a small group, and logs periodically need to be cleaned up. Logs are also only usually looked at when something goes wrong, after the fact. Logging and alerting can miss application issues until they reach a threshold of errors. Monitoring and observability changes where and when the decisions about normal or not occur. An application just sends everything to a different system. Analysis rules are applied there, patterns of activity are watched by specialized analysts, and anomalous activities can be caught before they become a problem. This platform sends alerts and provides a basis for auditing in case of regulator questions. A pro tip here is to keep an eye on OpenTelemetry. This is an industry standards organization backed by the major players in observability and monitoring. Seeing what that group is up to is a good way to watch the industry, and you'll likely need to interface with one of their participants in the future. There was a short-lived trend as part of the startup culture big enterprises wanted to nurture, where teams were free to make their own technology choices. This sometimes went poorly and ended up with a hodgepodge of resume-driven development and incompatible systems, not to mention data issues. At previous companies I've worked, before we implemented some level of data governance, we wasted way too much time tracing the ontology of data elements. Implementing data standards is a way to spend more time developing and less time troubleshooting. Data governance, in part, means data has the same meaning throughout a company. Do we have clients or customers? And everybody uses that term everywhere. Data has the same metadata throughout the company. This includes the type, the length, and the precision. This is an especially difficult conversation where GUIDs and UUIDs are involved. Also, data has the same security implementation throughout the company. For example, employee tax numbers are always encrypted, and only an HR manager can see them, and only for very specific reasons. Another one, all technology uses the same schemas for APIs and streaming services. No longer do different teams make up their own API schema. This greatly reduces implementation time. Piggybacking on that, there is a growing use of industry standards, such as Findex or Swift. If you remember EDI, there was one standard for the 850 purchase order, but every vendor typically had their own implementation. The same for all the other documents. EDI tried to cover all industries, and being all things to everyone was part of this problem. The emerging industry standards don't allow for that. They are industry specific, designed by participants in that industry, and everyone uses the same implementation. They are also designed from the start to be much more friendly to APIs and other modern technologies than EDI has turned out to be. More and more companies are also establishing technology standards teams. Some of what these teams standardize on are the architectures. Are we serverless or are we using containers? The languages and platforms we use. To what extent do we or can we embrace open source versus purchased components? Ensuring the software supply chain security. And how do we review products we think we need to buy, and how do we make those purchases? The guidelines which come from standards teams are inevitably going to bring some changes to an enterprise. In my experience, some developers respond poorly to standards, with the mindset of, you can't tell me what to do, especially if their preferred language or platform is not in the standard. I say this as someone who has authored industry and corporate standards. We're not trying at all to diminish you and your skills as a developer. We're just trying to prevent colossal mishaps. We need you and your skills to be awesome, and you can be a very positive force for change. Positivity brings results and rewards. One final, non-tech, non-business driver of change is who is in the workforce and their expectations. I'm Gen X and recall that most of my last 20 years was spent at just 2 companies. If I had wanted to, it could have been just one company this entire time. Younger generations have a much more employment at will, to the highest bidder attitude, with fewer qualms about bouncing from place to place over a short period of time. Older generations are now becoming more used to not being in the office as much, which, when combined with a tech-savvy younger generation, the tolerance for what users will endure is much less than what it used to be. Clunky or slow applications with a poor user experience will frustrate users and drive them away. internal line of business applications have some wiggle room, but SaaS applications and commerce sites and apps do not. UI and UX will become more of a feature than it already is. This is a progression from slash menus to swipe right. Additionally, with such a diversity of coworkers and teammates, not merely in age, but literally everything else, be empathetic and treat people well. In summary, there will always be reasons for changes to our applications, including the automation of business and development processes, increased regulation, security concerns, flexible work locations, generational changes, and increased corporate industry standards. The major changes to our applications at this time include cross-platform and lighter UIs, reusable back-end services to add capabilities, shift resource utilization, potentially open new markets. We'll also see increased inter-application communication. We're going to operate in a reduced trust environment with increased user, application, and data security. Finally, observability and monitoring.
Rich Dudley, are you still on there for Q&A? It looks like you are. We'll bring you up here. All right, so we're waiting for Rich to come back real quick. Do want to point out that we have some articles. There's an article on the bottom of the page about Amazon Web Services in your application. Also, we have our enterprise application article challenge going on. So you can write enterprise articles, pay $100 for all approved articles, and the winner can get $1,000. And yeah, if this goes well, we'd love to do more of these. All right, Rich, I see you're back. Still don't hear you.
Hear me now?
All right, well, I don't know, do you know sign language at all? I don't, but if you do, maybe there might be some people in the audience. Then if there's any questions for Rich, go ahead and type in the chat window, and he can type in responses or pantomime. I'm stuck in a box.
He needs to hold up signs like
love. Marker bird.
Yeah, there you go.
Rich, actually, can you maybe type in the chat if people want to go download any code or samples or slides from you? Where would be the best ways to get that? And then we can get those and put them up on blogs.embarcadero.com later.
I'm telling you, this is the Love Actually way of doing things, Jim. It's the future.
There's a comment here. I think this is related to your session or just in general about using a web-based app here. It says, my experience is the opposite of newer being better, designed and faster. Typically, most web apps are designed by younger people, are poorly designed, pay no respect to user, and are slow. Now, I don't know that I completely agree with that. I know I've talked to a lot of like CTOs and managers and directors and stuff that are oftentimes excited about using web apps or Electron desktop-based web-based desktop applications because of the lure of being able to get there quickly and use more readily available junior developers. And I would say that not having enough experienced, seasoned architects involved does lead to trouble, because even if you are doing web apps, you still need to have somebody that, has been in the trenches and seen some things because they're going to be able to help make so Rich, can you type in if you can type in the chat window, might be easily there. Oh, he did. GitHub. I'll put that link in here. There is Rich's GitHub as well, where you can go out and download some of his samples. And he has the AWS Community Builders diagrams. Yeah, so he has some repositories out there. UI is difficult, and I like to mention generational changes are driving a lot of that. I'll have the slides up shortly. Okay, so he will put the slides up there. And actually, that is a really good point. There is certainly some. It's good to have your UI, especially evolving, but you need to be aware of the forces out there. What are your users using, right? And as your users are using new platforms and new experiences, you may not like TikTok, but if you're not aware of TikTok, then you're not going to be able to understand your users as well. And so you need to understand what your users are using, what platforms they're using, and what applications you're using, and do evolve your UI and your experience around that. All right, it's too bad your microphone's or audio's not working, Rich, because I commented earlier, you have a great speaking voice, your NPR voice. But yeah, we'll get together and work on some more stuff later. In software does a lot of really cool stuff. I'm a big fan of everything you guys do. So thanks for putting the session together, and thanks for all you're doing there. And definitely let's stay in touch and work on some more stuff in the future.
I'll get the heads working.
Cool. So I'm going to go ahead and we'll move on at this point, I guess. But Rich, if people go to your GitHub page, it does have your email address and your website, so people can follow up with you on there. And if they have questions, connect to you there. And I will certainly be connecting with you too, because you have some cool projects in your GitHub repository. And in software does so many cool things. So we will talk some more. So this is a not related question, but saying that dev C++ is not supporting graphics.h and no output is coming. File an issue on dev C++, please, on that with more details, and we will see what we can do to update that. Oh, and then Richard's put his Twitter in here as well. You can contact him on Twitter or email or GitHub. All right. Thanks a lot, Richard. Sorry for the audio issues. I don't know. Sometimes it works, sometimes things don't, but that's life.